On June 27, 2026, Germany recorded its hottest temperature yet, 41.8 degrees Celsius. And I know what a lot of you are gonna say, oh, that's not that hot, it's so much worse where I live, but we don't have air conditioning here. And many of these buildings simply weren't designed for the kind of heat we're seeing these days. So the places where people are supposed to find refuge from the heat can also get uncomfortable, and in some cases, unsafe. Europe may not be the hottest continent, but it's the fastest warming one. In 2026 alone, extreme heat is estimated to have killed more than 25,000 people here. Cities can't rebuild all of their housing for this new reality, but they can adapt the buildings they already have. And no, that doesn't necessarily mean more ACs. Hello, welcome to my crib, or my hot box, I should say. It's nearly 30 degrees in here. That's almost as hot as outside. I think it's 31 outside right now. So there are a couple of reasons why it's not great to be in this apartment during a heat wave. One of them is my windows. They're pretty big, they let in a lot of light, there's not much shade, which is also partly on me for not having installed curtains yet. The other thing is I live on the top floor, which means that the only thing separating me from the scorching sun is the roof. So roof insulation is super important, and it's not always a given in old buildings. And if you look over there, you can see that the flat part of the roof has this dark material on top. It can heat up really quickly in the summer. But it's not just Berlin. People across Europe have been frying in their own homes. They're all over social media showing DIY hacks from Paris.
It's so hot, it's so hot, it's so hot.
London.
I'm having my third cool bath today. I feel like a Victorian woman.
And Amsterdam. In my apartment, I can minimize the damage by cross-ventilating, and I should get some curtains stat. But these things will only get me so far. So why don't we just install air conditioners everywhere? Adoption is still relatively low in some parts of Europe. In France, about 24% of households have installed an AC unit. In Germany, it's 6%, and in the UK, only 5%. Compare that to the US, where almost everyone has one. And studies show that residential ACs have helped reduce deaths during extreme heat.
Air conditioning is a wonderful technology which helps a lot to decrease indoor temperature and save lives.
This is Matteo Santamores. He's a professor of high-performance architecture at UNSW in Australia.
But at the same time, air conditioning is associated with many problems. Energy problems, environmental problems, health problems, financial problems.
That's the thing. Climate experts have warned that ACs are not the silver bullet in the age of climate change. First of all, they guzzle energy. Space cooling accounts for 10% of global electricity consumption, and this is largely driven by air conditioning. That can mean higher bills and overloaded power grids. When that energy comes from fossil fuels, we get stuck in a vicious cycle. Because it's so hot, we run ACs with sources that emit greenhouse gases and make the heat even worse. And air conditioners don't make that warmth disappear. They move it outdoors, adding even more heat to cities already packed with concrete and asphalt that soak it up. But there are ways to keep buildings and cities comfortable without relying on mechanical cooling. These measures are called passive cooling. According to the UN, putting passive techniques first could cut global cooling demand by 24% by 2050. So I met with Eike Rosva-Klinge, an expert in climate adaptive architecture, to find out how we can prepare our buildings. Step 1, finding their weaknesses.
Die Häuser aus den unterschiedlichen Epochen haben sehr unterschiedliche Phänomene. Und deswegen muss man immer sehr auf die einzelnen Häuser schauen und da dann entsprechend auf das Haus angepasste Lösungssysteme entwickeln.
In this corner of Berlin, you can see several eras next to each other, like the Gründerzeit. As German cities expanded in the late 19th century, streets filled with buildings that were several stories high, had elaborate facades, high ceilings, and massive load-bearing walls. You'll notice some of these features in other countries too, and they can work pretty well in the heat. These buildings weren't insulated in the way modern buildings are today, but this masonry is so thick it can take the heat a while to get through all this mass. Once they do warm after several hot days though, they're slow to cool down. And roofs can be another weak point. The space under them was usually meant for attics or servant quarters, meaning builders didn't care much whether it was comfortable. Paris's characteristic zinc roofs can heat up to 80 degrees Celsius. Some older buildings also have flat roofs covered in bitumen, a thick crude oil-based material that keeps water out. Great against rain, not so great when it bakes through a heat wave. These star covers are also common on structures that came up in the construction boom after World War II. In much of Europe, the priority was rebuilding housing quickly and affordably, not meeting the kind of energy standards we expect today. Many have thinner walls and poor insulation. And finally, there are buildings from the 90s and early 2000s like this one. You know the look, it's giving glass box. Berlin especially was in the middle of another building spree after the wall came down. Glass became a hallmark of the city's new modern architecture, bringing light into those dreary winter months, but also lots of solar heat in summer.
Die sammeln wie ein Gewächshaus die Wärme, die haben am meisten Stress. Also man sieht so, das älteste Haus ist eigentlich das, was am besten performt, hat sich am meisten an das Klima anpassen müssen.
In the middle of this glass building frenzy, Eike Roswa-Klinge decided to design his own home in the 90s, a new wooden apartment at the top of a pre-war building. Unlike most builders at the time, he wanted to create a space that worked with the climate.
Ah, es ist voll kühl. Voll angenehm. It's much cooler in here than outside. And it's the last floor, so that's crazy.
It's also much cooler than my own top floor apartment. This place has several ways to ward off the heat. The walls are framed with timber and insulated with natural materials like wood fiber. They have low thermal conductivity, which means heat has difficulty moving through them. So you need a thinner layer than for masonry, for example. Then there are also shading devices, a green roof, and green facades. We can use all of this as inspo for our overheated buildings. If you look at traditional architecture in hot regions, you'll notice the homes often have windows that don't let in a lot of light. A sharp contrast to these glass boxes, which often need air conditioning to stay comfortable.
It is crazy, really, to have a building which is glazed without any shading device. So we allow solar radiation to enter the building and then we spend electricity to put it out.
Experts say one of the easier ways is to create shade with external structures. Think shutters or awnings. This can work across different building types that get a lot of direct sunlight. It's already pretty common in hotter parts of the world. But in places that have historically been cooler, coverage can be a bit patchier, which is why many people MacGyver sun protection from things like emergency blankets or bed sheets. But proper shading systems can often be installed retroactively. In Eike Roswa-Klinge's building, there is another way of creating shade: plants. Besides protecting the facade and the courtyard from the sun, the vegetation cools the air through evaporation. And this greenery extends all the way from the bottom to the top.
It's such a stark contrast to see like all of this green and the rest of the roofs here in Berlin are like pretty much all black.
This roof is also covered in black bitumen, but it's been reinforced with copper to keep roots from penetrating it. And on top, there's an 8-centimeter layer of expanded clay planted with drought-resistant succulents.
Und das Dach speichert in dem Blähton und in den Pflanzen Wasser. Also wenn es regnet, staut sich hier das Wasser an und läuft nicht gleich runter und verdunstet das dann nach und nach. Und damit kühlt durch das Verdunsten des Gründachs wird das Dach gekühlt. Das ist eigentlich so die beste Form, ein Flachdach quasi sommerresistent zu machen.
And besides that, it works as an added layer of protection from the sun.
Wenn es mal komplett ausgedörrt ist, dann ist es trotzdem noch eine sehr große, sehr dicke Schicht, die das Sonnenlicht bricht und verhindert, also verschattet und verhindert, dass die Temperatur der Sonne in das Dach eindringen kann.
All of this can lower temperatures in the apartment below by a few degrees. Experts say greenery can be a relatively simple retrofit on flat roofs, provided the existing structure can take the additional weight and the waterproofing is up to the job. Other ways of shielding rooftops are to cover them in solar panels or paint them with a reflective white coating. Alright, but what are we going to do about the building's envelope, the walls? As we saw earlier, post-war buildings are sending out the biggest SOS. They don't have the sheer mass of an older building, and many have poor insulation. Insulation is basically a layer of material that slows the heat from moving from one place to another. It works both ways, keeping warmth in during winter and heat out during summer. Upgrading the insulation can look like this, manually adding it to the outside walls, then plastering over it. But some companies are trying to streamline the process by prefabricating new facades, like EcoWorks here in Germany. The company first scans the building to create a 3D model. Based on that, it manufactures custom facades with wooden or fiber cement cladding, which are then brought to the site and attached. The package also comes with roof modules, new windows with shutters, and in some cases, the heating system is upgraded too. I went to check out one of these construction sites in Berlin.
What we're seeing here, like this is the old building basically.
Exactly.
And then we have some insulation and then this is the prefabricated.
Exactly. The whole prefabricated module comes with insulation inside. It actually makes the temperature inside like much stable throughout the year. So that means we have cooler apartments during summer and warmer apartments during winter.
According to EcoWorks, this can reduce indoor temperatures by up to 6 degrees Celsius on hot days, depending on things like how much direct sun the windows get and how much cooling vegetation surrounds the building. And prefabrication can get buildings to that point much faster, because most of the work happens off-site. Anita Stankova tells me this installation is going about 3 to 4 times faster than a traditional retrofit, meaning this 1950s building is going from this to this in just about 3 weeks.
So we address mostly the buildings that are like from the 50s up till the 80s, because they have all similar characteristics. That means that have similar design. They're freestanding and have a quite rectangular shape, as well as very poor insulation and outdated heating systems.
That means it can work on similar building types all around the world. But the system gets trickier with older, more ornate buildings. Try wrapping a prefabricated facade around this. In these cases, if the building needs more protection besides its thick walls, it has to be insulated in the traditional way, without these ready-made modules. The thing about these solutions is we know how to implement them, but there are still some roadblocks. For one, getting everyone on board can be complicated if you're renting or a building has multiple owners. It's much easier when a single housing association manages several buildings. That's where EcoWorks gets its commissions from. Then there's the question of who pays for all of this. Prefabricated facades, for example, are still more expensive to install than conventional retrofits. There is government support, though.
The government in Germany offers many incentives. Some of them are in form of, like the subsidies in form of grants or low-interest loans.
But most of Germany's renovation incentives are geared toward energy efficiency more broadly. There's a wide range of eligible measures, from insulation to new windows to heating systems, while specific protection from summer heat is only one part of the program.
In former times, winter energy heating demand was the only thing Germany focused on. And now we must switch and also take the summer overheating and problem into account.
Heiko Wörle is a team lead for the engineering firm that co-wrote this heat protection report for Germany's Environment Ministry. The report points to another gap. When an existing building is renovated, there's currently no requirement to prove that it will be protected from summer overheating. The authors recommend changing that. That doesn't mean energy efficiency upgrades that already exist are useless in summer. Some can do both jobs. Insulation works year-round, and if active cooling is really needed, there are heat pumps. These high-performing electric systems move heat into a home in winter, but reversible models can flip the process in summer, moving heat back out. That would still warm surrounding areas, but it can provide energy-efficient air conditioning.
So it's also a question of how do we operate our system in the future in terms of heating, and can this heating system also be used for a cooling purpose?
And Germany isn't alone. Across Europe, summer heat is starting to creep into renovation policy, even if it isn't the main focus yet. London, for example, is investing almost £59 million to improve thousands of homes, with the explicit goal of making them warmer in winter and more comfortable during heat waves. France has launched a government tool that helps municipalities choose and plan cooling measures, like the ones we saw in this video. And some of the money is coming from the EU itself. Its LIFE program funds climate adaptation projects across the bloc. What this shows is that these cities designed for a different climate reality are not doomed, if we adapt.
Please improve the quality of our buildings, improve the quality of our cities, and then use air conditioning when it is necessary.
The question isn't whether we know how to prepare our buildings for the heat, it's how quickly we can actually do it.
Has your home ever been retrofitted for the heat? Let us know in the comments, and don't forget to subscribe to our channel.